Hey everyone, I have put this little video to walk you through how to calculate your data from experiment 8. And that's the experiment in which we took the yeast cells that had been grown overnight, had been centrifuged into, you get a little pellet at the bottom of a tube, and then we added cellulitic Y to that to break open all the cells to spill the proteins out into the solution. And then we took a sample of that out, and then we went ahead and put the bulk of that material on a DEAE column and separated it. And what you see on the screen here is the data from that experiment. So here, this is the lysate samples, the neat 1/4 and 1/8, 1/2 and 1/4 dilutions. And here's the load 1 and 2 samples. In my case, the load 1 sample had much higher concentration than load 2. The same thing happened here. So this is the experiment. This is the wild type that I did, and this is the mutant that I did. In this case, we have here, this is load 1 here as well. So keep that in mind, that's load 1, and these will be the wash 1 through 5, 0.1 molar elution 1 through 5, 0.3 molar elution 1 through 5, and 0.6 molar elution 1 through 5. So just get you oriented here. And these samples right here are the Pnp standards. We'll make a standard curve here. You notice this makes a big jump here, and I'll walk you through that right now. So what we did was I always start off with doing a Pnp standard curve. And here it is. We started off, it was 500 micromolar. Unfortunately, the way that I wrote up this protocol, I made an error, and actually the second sample is actually 125 micromolar, and I'll just go ahead and calculate from there. Equals this divided by 2, because remember we did 2-fold serial dilutions. And yeah, that's as far as we went, just 31.25. I think you only did 4 samples. This one we're probably going to, we may use and we may not use. It may be too high on the curve. So what we'll do here is, this is the standards of 500. So we go here, that's D and E. So what we'll do here is equal to average of these two. Hit enter. And we'll just go ahead and calculate these down. So here's the standard curve, and what I'll do here quickly, let's see here, I don't know why it thinks there's an error here, but that's okay. There's equations here and there's not an equation here. Okay, so we'll go ahead and do the standard curve. We'll highlight these areas, go insert XY scatter, and you'll see here's a nice little graph. Move it over. I always like to see it in. What I'll do here is I'll right click on that dot and I'll add a trend line, and it'll post this thing off to the side here. And I always like, as you know, I always like to put the equation on the chart and display the R squared on the chart. So now we have an R squared of 0.9958, which is very good, and we have the equation that fits the line right here. What I've also been doing, and it's something I haven't done in a lot of the other videos, is I'm taking advantage of some other Excel features. It's a nice thing to do, particularly if you have multiple ones to do. Like I processed a number of these from you guys, your guys' data, and it's kind of convenient to go ahead and calculate like the slope here and the y-intercept here. So I'll go ahead and put y-intercept, and I'll have an equation for slope. So I'll just go ahead and click on the box here and go equals. I start putting intercept, double click here, and here you highlight the y values, comma, the x values, and hit enter. So there you have the slope. Notice that 2277, 2277. And the slope, I'll do the same thing. It's equal to slope. Double click there. It's going to be the same thing. Copy the y's and then highlight the x's. You know, I'm not sure exactly why it's in that order, but we have these two values calculated. Now here, I don't need to see this information. I actually would like to use this. So we now know we have a standard curve. Now we can, the standard curve looks very good. So now we can calculate all of the concentrations. So what I do in a case like this, particularly since my data set's broken up into so many little pieces, I like to go ahead and create a long table. And what I'm going to do here is I'm going to go ahead and type in load-1, load-2. So we did the load sample. So remember, you loaded the sample, and I had you collect all the stuff that eluted that came out of the column at that point. The next step, I called them wash. It's probably more properly called a re-equilibration phase, but I will go ahead and put that in there and go wash 1, 2, 3, 4. And notice Excel kind of tells you what it is. 0.1-1, and I will go ahead and go copy that down as well. 0.3-1. 0.6-1. So now I've created the names of all these samples. And what I'll do here is I'll pull the data from down in here. So this is equal to this sample. Hit enter. Then one directly below it, just copy it down. Wash 1. Oh my gosh. Be aware if you delete all this, you might have to highlight this area and declared as text. This is the way the plate reader exports the data. Let's just go ahead and change it all to general. And I have to redo this. It's equal to this value. Enter. And drag that down. So wash 1 is this sample right here. And I will go ahead and copy that down because that would be wash 1 through 5 and then 0.1 molar wash steps as well. So I'll copy those down. Is equal to, now this is this 0.3 and 0.6 molar washes. Hit that, hit enter, and then go ahead and drag that down. So this is all wild type, and I'll put WT. And this next column I'm going to generate is for the mutant. So I'll just put MUT, M-U-T, and I will do the same thing again. So load 1 is this sample right here. In your case, load 2 is always the one with more concentration. I'm not sure why mine that I did a couple weeks ago came out different than yours. So I'll put equals this sample, enter. I'm sure, and I got at least one more point than you did, so I had a different program in the plate reader. And do the same thing I did before. And what I do at this point is, after I've copied, I make sure that I've done all the copy steps right. I go ahead and look at the data. I compare 0.3785, 0.3875, and look at 0.3912, 3192. So I verify all these numbers to make sure everything's okay. Now, I have the data for the concentrations, and the reason I put this in the table is this is going to make it easier to graph, and it's going to make it easier to do calculations. So I now have, a nice long string and building a big table full of numbers. So I will call that Pnp, wild type Pnp, and I'll call that mutant. Pnp. Okay, so now remember, if you rearrange, and I'll make this text so I can do that easier. Remember the equation is y is equal to mx plus b. So let's rearrange that because we're going to calculate x, the concentration. So we need to go backwards. So mx is equal to y minus b. And then you divide both sides by the slope. So x is equal to the quantity y minus b divided by m. So what I'm going to do here in this equation here, and in this column here, is I'm going to do this calculation. And here, the y-intercept is this value up here. The slope is this value right here. And I don't have to type it in. And that makes it so that there's some advantages to doing that, particularly if you're doing a number of these. So here we'll go ahead and do this. Is equal to y is this value right here. That's the absorbance. Minus the y-intercept, which is here. Close that off. But we want to have that fixed in place. So we'll change, if you put a dollar sign in front of each character, it'll make that reference non-relative. It'll make it only go to this number because it will be constant to the whole thing. So we have that. And what we can do here is stretch that across that way. It'll calculate those two. And then we'll go ahead and go down and calculate all of this right here. So all of them been calculated. So we have all the concentrations. So that's all nice. That's all good. So what we can do here is, what I like to go ahead and do at this point is I like to go ahead and graph the data. And we'll look at it, and we're going to create a more complex graph shortly. But I want to go ahead and just, at this point, I always go ahead and try to see what did the data look like. And here we'll go. We'll go through here and we'll highlight all these, the names of everything. And then we'll do the concentrations of P and P. So I'll just hold the control key down and copy all of these values. So I'll highlight again. So now I'll go through insert, and in this case, since it's not going to be an XY plot, formerly an XY plot the way Excel thinks about it, this is actually be a line plot. So I'm going to click this icon right here, which we haven't done much this semester, but I'll go ahead and click here. And I like to have the little dots so I know where things are turning. So we'll go ahead and do that. And we have a graph here. So here, load 1 has a lot of activity, and the beginning of wash has a lot of activity. I suspect that this value is artificially low, and maybe I switched these two samples. I'm not sure what I did, but here we have a lot of extra here. So this is what the plot will look like. So we don't have a huge amount of enzyme activity. You have a lot of enzyme that flow through the column for reasons that I'm not completely sure of. And actually for the experiments, for the kinetic experiments, which you guys have already done when I'm doing this, creating this video, you've already used this load sample for all the kinetics because that's where most of the activity was. Ideally, you see this little bump right here? This is where the enzyme was supposed to come out, and only a small amount came. So only a small amount bound to the column. And actually, this experiment I'm doing here was kind of an experiment to investigate loads. So what I'm going to do here next is I want to compare, now how did the mutant also look? So I'm going to do here is I'm going to go to select data. What I'll do here is I will change the series name to wild type enzyme. And click OK. And next I'm going to add data. And here it's mutant enzyme, and I'll go click here, and we'll go ahead and highlight this information right here. Click that. And now we have a graph that has both of them. And you see they're virtually identical. And you only see the orange up here. I'm not exactly sure why it's looking this way. Okay, the data overlap, so it was just kind of a refresh thing on my screen. So they both look very similar, which is kind of almost what we expect to see at this point. The next thing we need to do, and I usually go ahead at this point, I take advantage of some of the other features in Excel. It has these multiple tabs. So I'm going to go ahead and change this name to enzyme activity, because every now and then you have to come back to data sets, and it's kind of nice to see, have some things to guide you along the way to remind you. I'm going to open this tab here, sheet 1. And what I'm going to do here is, remember we did protein concentration determinations as well. So I have a spreadsheet up here. And what I'm going to do is I'm going to highlight that spreadsheet, copy it, move it out of the way onto the other screen you won't see. And here I'm going to hit paste. So now this is all the protein data. And you notice here it's the same thing. This is, the wild type. This is the mutant data, and this is the standard curve. And the standard curve we started off with 2 milligrams per ml, so I'll put a 2 here. And the next one down is equal to this one divided by 2. Hit enter, and we can drag that down to about here. So we have the concentrations determined. So this is concentration of protein. And this is the absorbance values. So remember we did in duplicate, so it'll be, I'm going to go ahead and take the average of these two, hit enter, and then we'll just copy this down. And to highlight them, insert, XY scatter, we'll do this, look at it, my standard curve here doesn't look as nice as some of them I've done, but I'm going to click right click, add trend line, and I will go ahead and display XY, X on the chart and R squared on the chart. Even though you see a few points off here, the standard curve overall, the fit is very good. It's almost, it's 0.992. I like to have my standard curves at least 0.98, and so this fits well within that parameter. And we'll just go ahead and do the same thing we did in the prior experiment. We go ahead and I'm going to put intercept and slope. Highlight the Y's, highlight the X's, hit enter. The same thing here, equals slope, Y's, comma, X's. And I have trouble remembering that frequently. So keep in mind, in this case, in this equation, you have to put Y's and then X's in. And then, so we now have the slope and the intercept. So now we can determine the concentration of all these samples. And what I'll do here is I'm going to repeat the same thing I did before. Load 1, copy it down. So I did, and this is why I kind of had you guys label these things sort of this way, because it makes it one step easier to go ahead and generate all these names. Come to think of it, I probably could have copied the same column over from the previous sheet because I'm putting them in the same order. So now I'll go ahead and copy the data down. So here's load 1, enter, copy it down. Is equal to wash 1, which is this sample, hit enter, copy it down to here. Is equal to this one, enter, copy it down to the end. Excel can do a lot of convenient things for you. And I'll put wild type here and mutant here. And what I'll do is this is the next thing I'm going to do. I'm going to put protein here and protein here, PTN. So because I'm going to copy all this data yet to the other sheet, but I can do all the calculations for protein concentration all on one sheet. So all the calculations in this sheet are all related to protein concentration. And this one will be enzyme activity. We'll do some other things with that. So we'll go ahead and I just want to make sure you know this. So I'm going to change this tab here, rename it the protein stuff. So I'm here. And I'm going to do is equal to this value, hit enter, copy it down 1. This is equal to, we know it's up here, hit that, go ahead and copy down, is equal to this, hit enter, and then I'll copy that down. And remember our equation before, that we need to do the calculation, we need to have y is equal to y, x is equal to y minus the absorbance values minus the y-intercept divided by the slope of the line. So we'll do that calculation again here. Is equal to concentration of y, which is the absorbances here, minus the intercept, and we'll make these fixed in place with put the dollar signs here. Remember to do this or else you get some really strange data. Oops, and go ahead and divide by the slope. Put dollar signs in. And we'll put wild type. Concentration of protein. And mutant concentration of protein. What I'll do is I'll copy it this way. This is the same calculation, and I'll copy down this way. So we now have the concentrations of protein, and what I do at this point, like I did before, I will go ahead and generate a graph, highlight that information. Whoops. And hold control down, do this information right here. Go ahead and put insert line graph. I like the little points here like that. And we see, oh, we have, we see a little bit of difference here. We see some of the things happening here. So this little bump of protein is a protein that's not, it's a protein that's not related to the enzyme. Remember, there was no activity here. So this will be kind of interesting to see. We see a little bit of some bumps of protein coming out. Be it if we could have more material stick to the column, we would have bigger bumps, hopefully. I'm not sure why that's happening, but it is. And let's go ahead and now add the other data. And we'll go ahead and go to the Select Data button up here. I'll edit the series, and this is wild type protein. Let's do it this way. Oops. Okay. Now I'll add the other one in. And this series is mutant concentration of protein. Hit that little button there to highlight, to select these. Oops. Enter. So we see that we actually, for the mutant, we see that the mutant was a nice little bump of protein here, and in the wild type, there was a bump here and there. So it's kind of interesting, and we had the similar size bump at 0.6. So here we know what the protein concentration looked like. Now we've got two independent graphs here, and looking at sort of things. I think there's some interesting things to represent this data, and we'll go ahead and talk about those next. So right now it's taking a little while to do this. So what I'm going to do is I'm going to end this video so we have that basic information already captured. And what I'll do is I'll create a second video to go ahead and show you how to generate the final graphs that I would like to see in your reports. So stay tuned for the next video, and we'll see you later, and good luck. Thank you.